So for our example here, for our last example of the section, we're going to suppose we have the statements P, you are 17, and Q, you are eligible to vote, where we want to express the statement P implies not Q, along with its contrapositive, converse, and inverse. So, starting with our original flavoring, we have something like P implies not Q, which can be said as, if you are 17, then you are not eligible to vote, which is true at least in America, where the voting age is 18 and up. Then from there, if we want to get its contrapositive, we flip the truth and the order, get something like if Q then not P, which we could write as if you are eligible to vote, then you're not 17. Again, true for basically the same reason, although it does leave the door open a little bit for other cases, and that's why our converse and inverse don't tend to function in quite the same way. That if we flip the order without changing truth to get the converse, we would have not Q implies P, which says if you are not eligible to vote, then you are 17, which in Florida and many other states, despite legislation against this very practice, wouldn't be true because convicted felons cannot vote. And convicted felons, most of the time, are older than 17. Meanwhile, for the inverse, we flip the truth of each component, get if not P, then Q, which says if you are not 17, then you are eligible to vote. And besides the felons that were just mentioned, we also have, in that case, the whole host of people between newborn babies and freshly minted drivers in the state of Florida who cannot vote because they are also under the age of 18 while not currently being 17. And then to be clear, to get a little bit more detail in this, we could think about what's going on with the truth tables here to see this equivalence more cleanly, can't talk right now, between the original and the contrapositive, that you can see both are false when each case is true and true otherwise. Meanwhile, we can see that the equivalence for the converse and inverse is essentially flipped, that they are true when both are true, true when either is true, and false when both are false. And for that matter, we can even think a little bit more cleanly about our statements as well. There's lots of ways we can get to this idea here about what is and isn't equivalent for our variations on the conditional if we want to be sure about how these function. But that's about all we've got here for section 3.5, so let's move on to finish off this chapter and our unit. It's only a one-chapter unit because this is some pretty involved stuff in here, looking at how we can negate conditionals, as well as finally bringing De Morgan's laws into the fold for statements. See you in there.